Hi, so I'm going to talk about the front end. Our front end is running with JavaScript, HTML, and CSS, and it's served with Nginx. Our styles are located in this styles directory. They're all broken into different files to make it more organized, and they're all imported into this file called styles.css. So for our pages, these are all of our pages in this course directory. You get here in the URL bar by typing in /course ID /interactions, for example, to get here. And you can see that each HTML file has this common.js to load all our JavaScript and this styles.css file that I showed earlier. Now for our web components, we use a lot of web components in our app. We have a toast web component to display toast messages. We have charts, so for attendance, interactions, and pulses. And for example, let's just check this out. You can change the attributes to display what kind of data you want to show. So you can query based on entire class and different parameters that you can change. And so for our forms, we have this conductor form.js. That's a wrapper or a parent web component, and all of our other forms in our app go through there, so we can handle errors and stuff in a standardized way. For example, journal form, you can see that all you have to do to create a form is to override these three functions. You have to give it all the fields that you want, and you have to tell it what to do on submit, and then it handles the rest. We have more components, but for the sake of time, let's go back to our JavaScript folder. Here we can see, let's start with fetch Every communication with the backend goes through this function to standardize it. And we can see that we have different wrappers for different methods. So we have a get wrapper and we have a delete wrapper. And if you go to our API folder, you can see all of the all of our functions that call our backend APIs. So in lectures.js, we have all of our lecture endpoints. Another interesting thing is we have this cache utils file where we can where all of our caching is handled. So we have local storage caching and cookies, and you can see over here all of the things that we cache. And this is so that we don't have to call the backend multiple times, and we can get data easier from certain paid places in our app. You can see our common.js, which this is where everything is imported into, and it's added to our HTML files.
Okay, so in this video, I'm going to walk you through our backend code base. So as you dive into the backend directory, we firstly have a README file which has all the steps related to setting up the system either locally or in Docker, right here. And so this will walk you through setting up the environment variables. If you're doing it locally, how you get all the dependencies, create databases, everything step by step. And then as we jump into the actual code, the source files, we have a directory structure that's inspired by Fossify's recommendations. So we have decorators, hooks, plugins, services, and utils. And the services essentially are a very modular way of organizing all of our code. So if you take a look at the features, we have attendances, auth, course, journal, etc. So let's take a look at the course uh, module. Within each module, we have the same set of files, permissions file, a repo file, routes, schemas, services, and index. So we first start with the routes file. So what routes file essentially is where we define all the different routes for that particular module. And it hooks up the service, the repos required, and then for each route, it just receives the request and then passes on to the service. The service is where we have all of our business logic. So all checks that we need to do with data, any business logic of whether you're a professor, what stuff you should see. If you're a student, what stuff you should or should not see. That's handled in this file. Um, we also have the service file has access to a repo and also to permissions at times. So the repo is basically our wrapper around our Prisma ORM because we wanted to not be directly linked with Prisma. So this is a hexagonal architecture. Um, so our wrapper essentially has helper functions for accessing all the course resources. Um, we also have the permissions file where here we're checking essentially does this user have permission to see a particular resource or not. And if we get pretty complicated in this as well. So if we look at the Pulse permissions file, we're allowing or not allowing people, allowing or not allowing the request to go through based on the filters that they have passed for viewing a particular set of pulses. Um, and then schemas file, lastly, is essentially where we're defining our format for what the request body expects and what the response would look like. And what this is really helpful for is generating OpenAPI Swagger documentation. So um, you can see over here that we have a really good UI created with all of the routes loaded up. And for any route, you can just click into it and see what the required parameters are. If it has a request body that is needed, it gives you an example of what that data looks like. And if you click on the model, you also see what the required data is versus what's optional. Like section and join code are optional for creating a course. So with that, let's jump back into some of the other stuff that I want to show. So we talked about services. We also have decorators and hooks and plugins. So decorator is essentially some functions that we want to use across requests. So, for example, load course is something because most of our endpoints are nested under a course resource. We would want to load the course that we can restrict access to resources like, let's say, a lecture based on the course itself. So we have this helper function created, and then we can just access it directly inside the lecture's routes and say that, okay, before doing anything with this lecture, I want to first ensure that I load the course. And then we can condition based on that. That's very helpful. We also have something similar for auth. And then we also have hooks. So authenticate is a hook that's like a global hook. Every route that we have goes through an authenticated hook. If we want to whitelist particular routes to prevent authentication checks, we have these whitelists that have been created. We also have a test mode to bypass any Google OAuth stuff. So you can just provide headers and be able to access any particular user in your database using those headers. Yeah, I think that's pretty much it for the backend demo.
This project uses the Docker Compose to keep our runtime environment consistent across all the machines and CI. Instead of everyone configuring the services manually, Compose let us define the entire stack, like the progress, the backend, and the frontend, in one place. So it always starts from the same way everywhere. Compose also creates an isolated network so services can communicate simply by the service name. That removes the need of the hardcore IPs and eliminates a lot of environment-specific issues. We ping Postgres to a specific major version and give it a named volume, which keeps the database stable across restarts during the development. Finally, we rely on the health checks to control the stop order. The backend waits for the Postgres to become truly ready before starting, which prevents race conditions around the initialization and makes the overall boot process much more reliable. We also use two Docker files to define a clear build contract. One is optimized for the development, and the other is a production-oriented version that uses a multi-stage build. This keeps the final production image small and ensures that it only contains the dependencies we actually need in production. During the build, we also generate the Prisma client inside the image, which helps keep the builds reproducible. At runtime, everything is initialized through an entry point script that checks for the required Prisma artifacts and applies the immigration with simple retry logic. This makes the first startup more resilient to timing issues when the database comes online. This diagram shows our end-to-end testing and deployment workflow, starting from a code commit and ending with a live deployment. The process begins when a developer makes a code commit. Before anything is pushed to the GitHub, we run a pre-commit hooks locally. These hooks automatically execute ESLint, prettier, and JSDoc. ESLint checks for common code issues, and prettier enforces the consistent formatting, and JSDoc ensures documentation stays up to date. If any of these checks fail, the commit is rejected and the developers fix these issues before trying again. Once all pre-commit checks pass, the code is pushed to the GitHub, which triggers the multiple automated checks in parallel. First, the CI pipeline builds the project and runs unit tests to verify core functionalities. At the same time, our Docker CI workflows build Docker images and run tests inside the containers, ensuring the application works in the same environment used for the deployment. In parallel, the code climate analyzes the codebase for quality issues such as the complexity, duplication, and maintainability. All of these results feed into a single decision point. If any check fails, the pipeline stops, the pull request is blocked, and the developer must fix the problem before proceeding. If all checks pass, the code is approved and merged into the main branch. After merging, the application is deployed to EC2, where the server is restarted using PM2. Once deployment completed successfully, the update versions of the application is live. Overall, this pipeline ensures that the code quality, correctness, and deployability are continuously validated before any changes reach the production.